All right. So we are going to review quiz A for our angles quiz. And the first part, section 1, first says estimate each of the angles for this image below. So the first thing we need to do is figure out which angles are which. So here we have angle D. Here we have angle E. Angle F goes from here to here, and angle G goes from this line to this line. So angle D, when I'm looking at that, that is approximately a 30-degree angle. I know that from all the way going straight up and down to straight sideways, that's 90 degrees, and this looks like it's maybe about a third of the way there. So I think I actually measured this, and it is in fact 30 degrees, but anything within probably like 15 degrees of this I probably counted as correct. The next one, though, is the remaining amount. So I know that this is about 90. If this is 30, this angle E here represents the rest of the distance to 90. So angle E has to be about 60 degrees. And if I think that this is a 90-degree angle, those two angles should total 90 degrees. Now, F and G, angle F goes from, let's see, angle F goes from this green line here. So the angle is from there all the way to here. And so that is beyond 90 degrees. And it looks like considerably beyond 90 degrees. If it was 90 degrees, this would be going straight up. If it was about 30 more, it would be going about parallel with that line. So that would be about 120 if it was going about parallel with this line. But it looks like it's even further than that. So I'm going to add like maybe another 30 degrees to it. I think it is approximately 150 degrees. And then angle G should be the other part of that going from this direction, right, this line, all the way over here. So angle F and G put together, I'm going to erase this now. Angle F and G together, I know, should make a 180-degree angle. So if angle F is 150 degrees, angle G just has to be the rest. So angle G should be about 30 degrees. So which of these angles are adjacent? Well, adjacent angles are angles where they meet at the same vertex and they don't overlap and they share a side. So let's see, adjacent angles. Here's one. I see that these two, like this angle, angle D, and angle E, here's angle E, they both share a vertex and share a side. So I can tell that angles D and E, let's actually write that, D and E, angle D and angle E. Let's see, are there any other? Let's see, E and F are not, because E is, E's angle is here, and F's angle is, goes from here to here. And so I can see that they do share the same side, but they have different vertexes. Angle E's vertex is in the corner, and angle's F vertex is there. So E and F are not. F and G do have the same vertex. I see here is angle G is right there to there. They do have a matching vertex, and they have a shared line, and they don't overlap at all. So angle F and angle G are also adjacent angles here. Which angles are not adjacent? Well, we already looked at E and F. E and F we know are not adjacent because they have different vertexes. So E and F are not, just going to write this shorthand. E and F are not adjacent angles. And also because I know that E and G also are not. So E and G have different vertexes. And then D and F and D and G also have different vertexes because they these two adjacent angles have a different vertex than these two. So anytime we go from my two pairs of adjacent angles, D and E and F and G, we know that those are not adjacent. Which pairs are complementary? Complementary means that they are that they total. Complementary angles mean that they total 90 degrees, and they have to be a pair of angles to do this. So the one place that looks like it might be 90 degrees is right here. which goes from this line going straight up to this line going straight out. And the two angles that I see that make that up are, let's see, here is angle D again, is part of that, and then angle E is part of that. So angles D and E, angle D and angle E. Which pairs of angles are supplementary? I know that supplementary means that the two angles, that's why it says pairs of angles, total 180 degrees. So I always know that a straight line makes 180 degrees. So I have a bunch of straight lines here, but do any of them have a pair of angles coming out of them? This angle right here is the only one that is a straight line that has two angles coming out of it, right? So we have angle F is right there, and then the other angle is angle G. So if I put a little vertex right here, that's where that vertex is, where those lines take off, right there. These two angles together, F and G, make 180 degrees. So angle F and angle G. Okay, some people came up with different answers here. If you said, some people said D and G were also supplementary. That is also correct. And some people said that E and G are complementary, and that's correct too. If you have angle E as 60 and G as 90, or any combination that totals 90, then I counted this correct. And if you have these two, any combination of like F and G or D and G that total 180, I also counted that correct. But if they didn't match, then I might not have counted them correct. Let me know if you have any questions about the first one. Okay, problem 2 says, consider the 4 triangles at right, which are acute triangles. That means they have only acute angles. Well, when I look at them, triangle 1, that is definitely an acute angle. So is that, so is that. So triangle 1 has all acute angles, right? I can tell because none of them they are all less than like this angle right here. This is a 90-degree angle. All of these angles are sharper than this. Triangle 2, some students said this one was, triangle 2 is also an acute triangle. All of those angles are acute, but some students looked at this angle down here and they said that's a right angle. And so it can't be acute, it has to be a right angle. So technically the answer should be triangle 2 is also an acute angle, or is also an acute triangle. But if you argued that that point there was a 90-degree angle, you know, I guess I think that's a valid argument. I think that that's just how you perceive the angles. And so if you said that was a 90-degree angle, and so this one didn't count, I counted this one correct for you. Also, some students said that angle 3, or triangle 3, that this is a right angle. And if that's a right angle, then this is a right triangle, just like number 2. But some students said that it was not, and that it was an acute angle. And if that is an acute, if you did not see that as a right angle and you saw that as an acute angle, like if that was 89 degrees instead of 90, since we didn't show you that, then you could technically argue that triangle 3 is an acute angle, or is an acute triangle as well. But angle 4, this angle here is definitely an obtuse angle. So if you said angle 4, you definitely got that one wrong. Anyway, so there were lots of potential correct answers for this one. Even though the other two angles on triangle 4 are acute, if there's one that's obtuse, it doesn't count. That's why it says have only acute angles. For problem 3, it says, with the given criteria, which of the following would make a triangle? If they would not make a triangle, explain why. So this one here, for side lengths, the 3 side lengths, each 2 side lengths have to be longer than the others. So we know that for any triangle, each side, like this side, side A, has to be shorter than B and C together. And side B has to be shorter than A and C together, and side C has to be shorter than A and B. So if this is side A, B, and C, and this side is 12, if this side, if I look at these two sides, what I usually do is I look at the longest side first, and then I ask, are the other two sides long enough to touch both ends of it? And in this case, 7 plus 4 is less than 12. So even if I connected these two and made a straight line with them, they would still not be long enough to meet. So if this one was 7, 4 would be like here, and they're just not long enough to meet. Like they're gonna be a little bit short. So remember, our rule for triangle irregularity is that A plus B has to be larger than C, A plus C has to be larger than B, and C plus B has to be larger than A. They all have to be large. Each side has to be shorter than the other two sides when you add them together. And in this case, 12 is not shorter than 7 and 4 when you add them together. So no, this one cannot be a triangle. Our rule about angles is that all angles for triangles, all angles must total 180 degrees. And so not more, not less, it has to be exactly. Let's write that in there. Exactly 180 degrees. So in this case, 73 plus 47 makes 120, and then 120 plus 50 more makes 170. So because the total angles are not equal to 180, this is not a triangle. So these can't be a triangle because they don't total 180. Part C, C says if the side lengths are 12, 13, and 5, well, so if I have a triangle that is 12, 13, and 5, let's say this is side A, B, and C. To just do my quick check, I usually do the longest side. Usually this is good enough. So 13 has to be less than 12 plus 5. So in this case, is it? 12 plus 5 I know is 17. Is 13 less than 17? The answer is yes. So this can be a triangle. Just to double check and make sure that I'm right all the way around though, I know that A plus B, so 12 plus 13 has to be greater than 5. That definitely is. 25 is larger than 5. 12 plus 5 is 17. That has to be larger than 13. And 13 plus 5, that has to be larger than 12. All of those are true, so this is a triangle. And the last one just says, we know that all the angles have to be 180, so I'm going to add these together. 24 plus 66. Well, I know that 4 plus 6 is 10, plus 20 is 30, plus 60 is 90. So this is, ooh, goodness, this is 90. And then now I have 90 plus the other 90. That makes 180. So this is a triangle because all of the degrees are 180 degrees. Okay. Go back, double